How to make a gear ratio that will take over 2,000 years to rotate. We can achieve this by applying the principles of gear reduction of classical physics. Gear ratios determine whether you increase or reduce speed. It all comes down to the principle of mechanical advantage, where there is a trade-off between force and speed. In this example, we have a chain of gears of the same size and same number of teeth. Here, there is no transfer of speed or force because the ratio is 1:1, meaning that both force and speed are going to be the same for all gears. Notice how the small gear needs to rotate 5 times in order for the large gear to complete a single rotation. You can also increase the velocity by rotating the large gear, which will multiply the rotational speed by 5. With a strong gear ratio and the correct number of gears, we can create a system that will take 2,500 years to complete a single rotation. We can create a chain reaction, where each gear will rotate 5 times slower than the previous one, creating an exponential growth in the time it takes to complete a rotation for each next gear. For example, gear number 1 speed is 10 revolutions per second. Gear number 2 is 5 times slower at 2 revolutions per second. Gear number 3 rotates at 2 revolutions every 5 seconds. We can lock our numerator at 2 revolutions to see how the denominator is 5 times greater on each new gear. The further you move to the right, the more static these gears look. In fact, they have the appearance to be frozen, but don't let them fool you. They are slowly moving, even if your brain cannot notice it.